Welcome to the Vitality Equation, exploring research in health and well-being one paper at a time. Today, we're diving into a fascinating study titled Plasma Insulin Like Growth Factor 1 IGF-1 Concentrations Predict Early Life History Traits in a Wild Mammal. It's a mouthful, but the implications are huge, especially when we start thinking about personalized approaches to health and well-being, right?
Absolutely. IGF-1, for those who aren't familiar, is like a master regulator of growth and development. It's been linked to everything from muscle growth to brain function. So, the idea that levels of this stuff early in life can predict later life traits in a wild mammal, that's pretty profound. It suggests a deeply rooted biological programming.
Yeah, and the fact that they studied a wild mammal is key, I think. It removes a lot of the controlled environment factors we see in lab studies. We're talking about real-world conditions, real-world stressors. So what exactly did they find? I'm eager to dig into the specifics.
Okay, so the researchers basically tracked IGF-1 levels in young wild soy sheep, a breed that lives on a remote Scottish island. They then correlated those levels with various life history traits like survival, growth rate, and even reproductive success later in life. What they found was a significant correlation. Higher IGF-1 levels early on seemed to predict better outcomes across the board.
Interesting. So, the sheep with higher IGF-1 were basically set up for success from the get-go. It makes you wonder about the implications for human health. Could early childhood IGF-1 levels be a predictor of, say, cognitive resilience or susceptibility to certain diseases later in life?
Definitely. And thinking about the physical aspect, could it predict things like bone density, muscle mass development, or even predisposition to certain injuries? You know, it makes me think about athletes and how early training and nutrition might influence their long-term physical capabilities through IGF-1 pathways.
It's a really interesting thought, and if early life is crucial, and this factor can be impacted by lifestyle choices, I want to focus more strongly on daily practices to influence those hormone levels. This underscores the profound impact of conscious choices on overall well-being. I feel a strong sense of motivation to make continuous improvements in lifestyle choices through mindfulness and holistic well-being practices for better hormonal balance.
Yes, and it begs the question, what factors influence IGF-1 levels early in life? Is it purely genetic, or are there environmental and lifestyle factors at play that we can actually modify? That's where it gets really exciting, because it opens up possibilities for intervention, right?
Exactly. And that's where my mind goes: exercise and sleep. We know that both play a huge role in hormone regulation. Could we, through carefully designed exercise and sleep interventions, potentially optimize IGF-1 levels in young children and adolescents to set them up for better long-term health outcomes? It's a fascinating idea.
It definitely is. I wonder if regular meditation and mindful movement practices can improve these hormonal markers. If IGF-1 levels affect early life traits, maybe meditation and mindfulness can be used as tools to improve them.
That's a really interesting angle. I'm curious about the cognitive side of things. Could stress, for example, negatively impact IGF-1 levels? And if so, could cognitive behavioral therapy CBT techniques, like stress management and cognitive restructuring, be used to influence IGF-1 levels in a positive way?
You know, it's all connected. Stress impacts sleep, sleep impacts hormone regulation impacts physical development. It's a complex web. And thinking about the wild mammal study, the sheep are dealing with stressors like predation, harsh weather, and limited food. Those stressors are going to impact their IGF-1 levels.
The idea of optimizing early life traits through lifestyle choices is quite inspiring. I can see how understanding these types of hormonal influences could empower people to make better choices, not just about their physical health, but also their overall happiness, as early life influences have a huge role in our life and our development. A more holistic approach to well-being might lead to a deeper sense of balance, purpose, and overall satisfaction.
And that's where personalized medicine comes in, right? It's not just about a one-size-fits-all approach. It's about understanding an individual's unique genetic predispositions, lifestyle factors, and environmental exposures, and then tailoring interventions accordingly.
Yes. Imagine being able to assess a child's IGF-1 levels, identify potential risk factors, and then design a personalized exercise, nutrition, and sleep program to optimize their development. That could be game-changing, especially for children at risk for developmental delays or chronic diseases.
Wow, so subtle hormonal factors shape crucial early life characteristics. This reminds me of the power of holistic well-being. If early life traits are influenced by these hormones, it makes sense to approach overall health improvements, not just through specific routines like diet and exercise, but also via a holistic lifestyle incorporating mindfulness, stress management, and deep rest. perhaps even incorporating nature into my daily routines.
This research suggests a potential avenue to apply CBT principles in a physiological context. If patterns of IGF-1 levels predict cognitive and emotional vulnerabilities, are there specific CBT strategies that could positively influence these levels and therefore modify the response to stressors?
If plasma IGF-1 levels correlate to early life traits in mammals, perhaps optimizing sleep quality could also play a role in boosting IGF-1 levels for improved health outcomes, similar to how sleep is known to affect hormone regulation.
Yeah, this connects with something I've been thinking about a lot lately, and that is how early life experiences imprint themselves not just psychologically, but also physiologically. And this study seems to provide some evidence for that. It's like our bodies are keeping score, you know?
The body definitely remembers. And I think it reinforces the importance of early intervention programs that focus on creating supportive and nurturing environments for children. Because it's not just about academic achievement, it's about building a strong foundation for lifelong health and well-being.
If IGF-1 levels in a wild mammal are linked to its early life traits, maybe I can use this understanding to refine my lifestyle choices for a more proactive approach to my overall well-being. What specific lifestyle elements could influence my IGF-1 levels? And how can I use this information to optimize my health? Yoga and meditation might factor in, since stress management is a key component of a healthy lifestyle.
Understanding how plasma IGF-1 levels relate to early life experiences could help tailor CBT interventions that address potential early development issues. This could be a pathway to more personalized, potentially preventative health strategies, moving beyond reactive treatments.
How might different exercise regimens affect IGF-1 levels in wild mammals? And could similar principles be extrapolated to human populations and help us tailor our exercise routines for optimal health outcomes?
Exactly, and it also raises ethical questions, right? If we can identify individuals who are potentially at risk based on their IGF-1 levels, do we have a responsibility to intervene? And if so, what kind of interventions are appropriate?
And who gets access to these interventions? Will they be available to everyone, or just those who can afford them? We have to be mindful of health equity and ensuring that these advancements benefit everyone, not just a privileged few.
How can the ethical considerations around altering natural biological processes be addressed, while ensuring the technology supports genuine human needs rather than just creating more designer products?
It also brings up the question of overintervention. Are we going to create a society where everyone is constantly trying to optimize their biology, potentially at the expense of other values like spontaneity and acceptance? There's a balance to be struck, I think.
Yeah, and we need to be careful about unintended consequences. Messing with complex biological systems can have unforeseen effects down the line. We need to proceed with caution and rigorous research.
The idea that we can now potentially design and enhance natural processes to create valuable products is incredibly inspiring, suggesting that there are infinite possibilities for promoting holistic wellness without the need for harmful substances.
If IGF-1 levels can predict early life history traits, could cognitive behavioral therapy CBT techniques be used to influence IGF-1 levels in ways that improve health outcomes, potentially by changing how the individual perceives and reacts to stressors?
If IGF-1 levels in early life predict later life history traits, understanding how exercise and sleep patterns might influence IGF-1 levels could be a crucial component of optimizing health and development. On that note, it's interesting to consider the role of the gut microbiome in all of this. We're learning more and more about how the gut influences hormone regulation, immune function, and even brain health. Could the gut microbiome be a key player in modulating IGF-1 levels and influencing early development?
That's a great point. And it ties into the whole idea of the mind-body connection. The gut is often referred to as the second brain, and there's a growing body of evidence suggesting that the gut microbiome can influence mood, cognition, and behavior. So, it's not unreasonable to think that it could also impact IGF-1 levels and affect early development.
Learning about how nature itself uses these clusters to synthesize complex molecules inspires a sense of wonder and potential. Could a deeper understanding of these processes help us optimize our own well-being by creating more harmonious interactions with nature, potentially through healthier eating habits and more intentional lifestyle choices?
Could manipulation of these gene clusters create more nuanced therapies for individuals, catering to their unique biochemical profiles and cognitive characteristics? This would revolutionize personalized mental health interventions, addressing the complexities of the human mind on a fundamental level.
The complexity of designing these gene clusters is incredibly inspiring, much like the intricacies of physical training regimens. I'm struck by how much focus is placed on optimizing biological processes for desired outcomes. It evokes a sense of wonder about the potential to improve human capabilities through meticulously structured approaches.
How can mindfulness techniques be integrated with the design process to ensure the resulting biosynthetic gene clusters are not only effective, but also aligned with principles of bioharmony? Could meditation help guide the design towards more balanced, less disruptive solutions?
The precision and potential offered by this technology is fascinating. I'm excited about the prospect of moving beyond symptomatic relief and truly understanding the root causes of mental health challenges by manipulating the molecular machinery within our cells.
Learning about how to manipulate biological pathways through genetic engineering sparks my interest in the intersection of exercise science and biotechnology. Could optimizing the body's natural processes improve the effectiveness of exercise and sleep routines, and thereby impact overall wellness?
This whole conversation has really got me thinking about the future of personalized health interventions. It's not just about treating diseases, it's about optimizing human potential. And understanding the role of IGF-1 in early development could be a key piece of the puzzle.
Absolutely. And I think it's important to remember that this is just one piece of the puzzle. There are so many other factors that influence health and well-being, from genetics to environment to social determinants of health. We need to take a holistic approach and consider all of these factors when designing interventions.
If biosynthetic gene clusters can be predicted and designed, could that lead to more natural, plant-derived health-boosting compounds accessible through sustainable methods rather than synthetic pathways? This could revolutionize natural health and wellness beyond supplements.
The ability to predict and design these clusters implies a deeper understanding of the intricate biological processes underlying mental health. If we can precisely manipulate these, we might find novel approaches to treating conditions like depression, anxiety, and even neurodevelopmental disorders that transcend current cognitive behavioral therapies.
This research seems to be about building biological systems. I wonder if there's any link to biohacking strategies for performance optimization, exploring the human body at a molecular level to enhance natural functions. Could this platform offer new avenues for personalized exercise regimens or sleep protocols?
So, what are some potential avenues for future research based on this study?
Well, from a cognitive perspective, I'd be fascinated to see studies that investigate the relationship between IGF-1 levels and cognitive function in humans, particularly in the context of aging. Could interventions that boost IGF-1 levels, like exercise or CBT, help to prevent cognitive decline? That's a huge question.
Yeah, and from an exercise and sleep perspective, I think it would be valuable to conduct longitudinal studies that track IGF-1 levels in children who participate in different types of physical activity and sleep interventions. This could help us to identify the most effective strategies for optimizing IGF-1 levels and promoting healthy development.
From my perspective, I'd be really interested in exploring the impact of mindfulness and meditation practices on IGF-1 levels, and by extension, on those early life traits and markers. Could these practices, combined with the exercise and sleep interventions, create a synergistic effect that optimizes development and well-being?
How can we translate this understanding of biosynthetic gene clusters into specific therapies targeting cognitive biases and emotional dysregulation? What are the limitations and ethical considerations in using this technology for improving mental well-being?
The idea of designing gene clusters to produce beneficial compounds fascinates me. Could understanding these processes help us to optimize recovery and repair in the body, especially after intense exercise or periods of sleep deprivation?
If we can predict and design biosynthetic gene clusters, it suggests a potential to reprogram cellular pathways in a targeted way, offering possibilities for novel cognitive enhancement strategies beyond traditional CBT. This opens up avenues for manipulating biochemical processes underlying cognition and mood regulation, which could be a powerful tool in therapeutic contexts.
If biosynthetic gene clusters can be designed for novel natural products, perhaps the same principles could be applied to metabolic pathways that enhance physical performance. Could optimizing gene expression for muscle protein synthesis be a key to improving athletic performance through exercise techniques? And you know what else? I think it's important to study the long-term effects of these interventions. We need to make sure that they're not just beneficial in the short term, but that they also have lasting positive impacts on health and well-being throughout the lifespan.
Definitely. And we need to be mindful of the potential for unintended consequences. As with any intervention, there's always the risk of side effects or unforeseen outcomes. We need to proceed with caution and rigorous monitoring.
Well, this has been a fascinating discussion. It's clear that IGF-1 plays a crucial role in early development and that it's a potential target for personalized health interventions. But it's also clear that there's still a lot we don't know. We need more research to fully understand the complex interplay of genetics, environment, and lifestyle factors that influence IGF-1 levels and impact long-term health.
Agreed. And we need to be mindful of the ethical implications of these interventions and ensure that they're used responsibly and equitably.
Absolutely. But I'm optimistic about the future. I think that with continued research and a focus on personalized approaches, we can unlock the potential of IGF-1 to promote optimal health and well-being for everyone.
Well, that's all the time we have for today. Thanks for joining us on the Vitality Equation. We hope you found this discussion informative and thought-provoking. Until next time, stay healthy and stay curious.